Hello guys, my name is Stephen and we've already done introduction to differentiation. So now we are going to do application of differentiation. And as we already learned, I told you earlier on that differentiation is applicable to many fields in science. So here we are going to learn how to use differentiation to obtain gradients of functions and how this particular gradient of functions is used in many fields. From there, then we move forward. So first application is obtaining the gradient of a function using differentiation. So how do we obtain the gradient of a function? You know, functions as we know can be rational, irrational functions and co. And even more irrational are those having the radical signs. That is, you can have a radicand 1 over square root of those things. Then you know how those functions behave. Some are continuous, some are not continuous. So with the help of differentiation, you can determine the gradient at a point at a particular instant, that is a point on the curve. So let's say you are given a curve whose equation is y is expressed in terms of y, or if the curve is a function, let's say f of x, and you are asked to find the gradient of this particular function at a point, let's say x is equals to a, then what you need to do is that you differentiate. Since this one is on a plane, these are always on a plane. But if they give you that of the one in space, you have to do a lot of differentiations and then computations to get that. But this one is on a plane, so it's quite easier. Then it's to your syllabus. So what you do is that you just differentiate the function given with respect to the other variable, that is the variable you are to input. You differentiate the output variable with respect to the input variable. Then you put or plug in the value given into the differential function after differentiating, and then you obtain your gradient. That is all. You will get your gradient. Simply as that. If you want to know what I've done, then let's look at this example. The question says that what? That find the gradient of the curve y is equals to x power 4 minus 1 over x squared plus 1 at x is equals to 1. So as I told you earlier on, what do we do? Okay, firstly, we will find the differential of the curve x is equals to y rather is equals to x power 4 minus 1 over x squared then plus 1. How do we differentiate this? Again, from the first videos, in order to differentiate this, you need to linearize it. So in order to do so, you have negative exponents here because it appears that it was a rational function that has been partialized. So in linearizing this, we will have x power 4 minus 1 minus x rather power minus 2 then plus 1. Then you go ahead to differentiate. In differentiating this, what will we get? We'll have dy over dx to be equal to, when we differentiate x power 4, we'll have 4x keep, because I'm assuming that you've learned how to differentiate. Then we'll have, when you differentiate this, we will have 2x then power minus 3, so plus 2x power minus 3. Then when we differentiate 1, we'll get 0, of course. Then what next? You will put the value given into the differential equation, and it is always written in this notation. So this is how you write it, and then put your 1 there. Then you will have 4 power 1, 4 times 1 power 3 rather, then plus 2 times in bracket 1 power minus 3. Same applies to the the other term, 4 times 1 in bracket power 3. So in evaluating this, what will we get? 1 power 3 is 1, times 4 is 4. 1 power minus 3 is 1, times 2 is 2. So 2 plus 4, 6. So 6 is our gradient at that instant. So that is it. And what do we mean by our gradient? This means that when you draw a tangent to the curve at the instant x is equals to 1, then that tangent, when you decide to trace a vertical line at any arbitrary point on the line, and also trace a horizontal line from another arbitrary line on the same point, make sure that those two lines meet at a particular point, making an angle of 90. When you do so, then the ratio of the vertical one to the horizontal one will be 6. The ratio of the vertical, the side or the length rather of the vertical side to the horizontal side would be 6. For example, look at what I'm talking about. Let's say this was the curve that we actually differentiated. So now let's say here is x is equals to 1. X is equals to 1. Then what we mean is that when we draw a particular tangent like this to that point, and we pick an arbitrary point like this from here, draw it downwards, pick another arbitrary point on that same line like this, then trace it vertically in such a way that the two lines traced from the two different arbitrary points make an angle of 90 degrees with each other, or are orthogonal to each other. Then the length of the side, the length of the vertical one over the length of the horizontal one should be 6, and that is the gradient, simply as that. So let's move on. So since you've understood this one, then that means that you can take this one as an assignment. Find the gradient of the curve y is equal to, into bracket, 2x plus 1 all power 6 at x is equals to 1. And again, this one, if you've learned differentiation already, it won't be difficult for you. So now this one requires the use of chain rule. So that is it. Go and do it. So let's move on. So right now that I've spoken about this, you ask me that where is this applied? those physics students doing AC theorem and other things, differentiation is actually also like it's also applied there, but you don't know. It is also applied there. It is applied in many folds. Many folds. It is applied in bridge construction and other things. In fact, many things. Integration, differentiation. So let's say we have a particular wire, that this wire is connected to an AC source. Though those not doing physics will not know, but it's connected to an AC source. And you are told that, it's electrons, the flow of electrons, that leads to current, like that leads to the flow of current. When electrons flow, then current will what? Also flow, but in the opposite direction to the electrons. So if electrons don't flow, then current will not also flow. So that is it. So they can tell us that at a particular instant, the electron flow is this. At a particular instant, the electron flow is this. So that means that the electron flow varies with time. Is that not it? So it can be written in terms of time, that the electron flow is equals to maybe 2 electrons in a second. So meaning 2 electrons, so 2 times t, then plus constant 5 electrons always flow, whether with time or not, they always flow. But at an instant, see that when maybe they began with 5 electrons were flowing, then as time goes on, 2 additional electrons added, and more time, 2 electrons, within more time, 2 electrons additional, 2 more electrons added, in that order. So that's why the T is here. So now we know that current is equals to the Q over the T. That is the rate of flow of charge. The rate of flow of charge, or the time rate of flow of charge, let's say so. So you need to differentiate this and use the instant that you are given to know the particular current, particular quantity of current flowing through the wire. Let's move on. Our next on this lesson, the next on this lesson is how to find the equations of tangents and normals to curves. The equations of tangents and normals to curves. So how do we do so? How do we do so? Firstly, you will be given the point at which those tangents and normals intersect with the curve. Do you know that a tangent intersect with the curve like that or not? You don't know. As it is tangential to it, it is considered as an intersection, but one point intersection. So are you now clear with that? So let's move on. So when you are given that point and you are given the equation of the curve, what you need to do is that you find the corresponding y component of the point. Sometimes they can give you both points, so you don't need to do so. But if they give you one point, you need to find the corresponding y component. Let's say if you find it, it should be b. Then of course we discuss of gradient function just right now. So after finding the corresponding value, you leave that one, you use the x value, differentiate the function with respect to x, plug in the x value, the given value, to get the gradient of the curve at that instant. Then know that, as I told you earlier on, that the 6 that we got earlier on was representing the gradient of a tangent to the curve at that point, tells us that then the gradient you will get will be the gradient of the tangent you are supposed to find. So when you find that gradient, then the next thing is that since that tangent is passing through a point that the curve through is passing through, it means that the point given lies on that tangent too. So that means that you have your gradient and you have a point. So you can use a gradient in a point to find the equation of the tangent. It is satisfactory. That is, the conditions for finding a line is satisfactory. Let's do that practically and we'll see. We have a question here that says that what? Find the equations of the tangent and normal to the curve. Y is equals to x power 4 minus 1 over x squared plus 1 at x is equals to 1. Of course, this is the same equation as the first one, so we'll not waste time. We'll go back to the first one. So given an equation like this, of course you rewrite it like this way. From this way, then you differentiate it like the given notation that I gave earlier on. Then you plug in your 1, you will get 6. So now this is our gradient. This is the gradient of the line. The gradient of the line is what? 6. And we know our x-axis value to be 1. Then we don't know our y-axis value. What will we do? We plug in the 1 into the function or the equation of the curve. When we do so, what will we get? We'll get y is equals to 1 power 4 minus 1 power minus 2 plus 1. And this will result to 1. It will give us 1. So the corresponding y value is also 1. So guys, have you seen that? Now we have our corresponding x value, y value, and then the gradient. What will we do now? We can now say our equation of a line, write it down. X minus x1 is equals to, sorry, y minus y1. You can write it the way you want, but let's write it this way. Y minus y1 is equals to mx minus x1, this way. But you could have also made this the subject, the whole, or in the bracket the subject, and take 1 over m, multiply by here. So that's why I said you can write it the way you want. So when you write it this way, what will we do now? Or what will you do now? You plug in this y1 is this, x1 is this, and then m is this. So you plug in everything. You have y minus 1 is equals to 6 times x minus 1. This will be equals to, y will be equals to 6x minus 6 plus 1. Y will be equals to 6x minus 5. And this is the equation of the tangent. So have you seen that, guys? Then let's move on. Let's find the equation of the normal. We know that from our knowledge in geometry 1, we know that when two lines are perpendicular, the product of their gradients should be equal to minus 1. Have, have you seen that? Or if you not learned that, or if not seen that today, then you are seeing it. Go and learn it. So we have the gradient of line 1 to be 6, which is perpendicular to the other line that we are to find its equation. of course, normal and tangents are always like cross rows, like they are perpendicular to each other. So we will have 6 times m2 is equals to minus 1. m2 is equals to minus 1 over 6. So that's the gradient of the normal. Then we know that, of course, when they are perpendicular to each other, passing, they intersect, and then, of course, they will intersect at the same place, because they said find the normal to the curve and not to the other tangent to the curve. And then you know that since this one is tangential, then the normal will also be normal to that line too. That's why. So we use this one and the points again. So we'll have y minus 1 using the same equation is equals to minus 1 over 6 multiplying by x minus 1. So we'll have 6y minus 6 multiplying both sides by 6 is equals to minus x plus 1. Then we'll have 6y is equal to 7 minus x. So this is the equation of the normal as well. So that is it. So guys, again, take this as your assignment. Find the equations of the tangent and normal to the curve y is equals to 2x plus 1 in bracket all power 6 at x is equals to 1. Let's solve this last question and meet another time to discuss many useful application of differentiation. Thank you. So let's move on. We have find A if the line this is normal to the curve y is equals to x cubed minus 2x plus a. Wonderful. They are telling us to find A. And where is A? It seems A is a constant in the equation of a line, the line. So how do we find A? How do we find A? How do we find A? So that's the question. How do we find A? So here we are going to find A. So good. Guys, let's find A. In finding A, guys, we know that our first equation, that is the normal, is equals to y is equal to 2x minus 2. Is that not it? And our next equation is y is equals to x cube minus 2x cube minus 2x plus a. Is that not it? They are saying we should find a. So 1, this is a normal to this, meaning it intersects this equation. Is that not it? So they should have a common point x1, y1. But at this particular point, the equation, the gradient of the curve will rather be equal to the gradient of the tangent to this particular normal and to itself. Are you getting that? Of the tangent to itself rather, but normal to this one. Are you getting that? So what will we do is that we will have to differentiate this one. So differentiating this, what will we get? The curve. We'll have dy dx to be equals to 3x squared then minus 2 as it. Then let's find the gradient of this. Comparing to this, we can see that the gradient is 2. This is y, this is gradient intercept equation. So the gradient is 2. But this one is a normal and not a tangent. So what will we do? We find a gradient of the tangent by using this. So we have m1 times 2 is equals to minus 1. Then we have m1 is equals to minus half. So guys, have you seen that? Then what will we do next? We'll have to put this particular one, equate it to this, because that's the gradient and is the same, to get our x value. In doing so, we will have, so guys, this is how we will do it. And then we will have, what will we get? Minus half plus 2. What will we get? We will get 3 over 2. Is that not it, guys? So we'll have x squared is equals to half. Then we'll have the x to be equal to plus or minus root 2 over 2, because you will get 1 over root 2, and rationalizing it will give you root 2 over 2. Simply as this. So we've had the x value. We've had the x value. Now that we've had the x value, can we find our a? No, we don't know y value. We can't find our a. So what will we do? But this and that intersect at this point. So meaning we can use this to find our y value, and replace it here to find our x value. So we say, when, since x is equals to two values, when x is equals to minus root 2 over 2, then we will have y to be equals to 2 times minus root 2 over 2 minus 2, which will give us minus root 2 minus 2. When x is equals to root 2 over 2, then we'll have y to be equal to 2 times root 2 over 2 minus 2, which will give us root 2 minus 2. So simply as this, as you can see, simply as this. So we move on. Good. So meaning you can replace this with its corresponding x, this with its corresponding x. So let's come to this equation. We've now had our x and y both. So let's say when x is this, what y will be this. Is that not it? Then we'll replace them here and find a. So we say when x is this, y is this, that means that minus root 2 minus 2 will be equal to root minus root 2 on 2, keep minus 2 minus 2 minus, in bracket, minus root 2 over 2, then plus a. So a will be equal to, using a calculator, a will be equals to, okay, half. Okay, A will be equals to minus 4.5. Okay, then you do for when x is equals to plus root 2 over 2. Do for that one. Thank you. Don't forget to subscribe, like, and share. Thank you. I hope you like my videos. Thank you. Next time I bring to you rate of changes, sketching curves using differentiation, and application of differentiation in motion, differential motion. Thank you.